Hey everyone. So our last trend is what we are talking about today. Okay, we went over atomic radius, we went over ionization energy, and today we are talking about electronegativity. Okay, electronegativity. It's all one word. I just kind of wrote it as two words there. So electronegativity. What is electronegativity? Electronegativity is an atom's ability to attract electrons. So all this is how long does it take, or which atom is more likely to attract electrons? Okay, we know some atoms like to give up electrons. We know some like to attract them to fill that outer shell, right? Well, let's go ahead and let's look at the trend up top. So make sure that you have your outline for your periodic table. And the good thing about electronegativity is it's the exact same as ionization energy. It increases as you go right and as you go up. So as we go up and to the right, it is going to increase. So elements that really want to attract electrons increase as we go up to the right, but the one thing is that noble gases are an exception. They have a zero electronegativity, okay? Why is that? Well, it's because noble gases already have a filled outer shell, right? They don't want to attract any more electrons. They don't react with anything, right? So all these guys are zero. So noble gases are zero, but then electronegativity increases as we go up and to the right. So please make sure that you exclude these guys, that you know that these all have an electronegativity that is relevant to zero. So let's go ahead and talk about why it increases as we go to the right. Well, this is just kind of similar to ionization energy, right? If we look at lithium, it's got 3 protons, okay? And it's got 1 valence electron. If we look at fluorine, it's got 9 protons, and it has 7 valence electrons. Okay, the thing here is, which one do you think is going to want to attract more electrons? The one that needs 7 to fill its outer shell, or the one that only needs 1 to fill its outer shell? It's going to be fluorine. Okay, so the reason why we increase in electronegativity as we go right is just because they want their outer shell filled, right? This guy has 7 valence electrons, he really wants just 1 more. This guy has 6 valence electrons, he wants 2 more, okay? He doesn't want them as bad as fluorine because he needs 2, but so on and so forth. But lithium, right, it doesn't want to attract electrons. It'd rather get rid of this outer electron in order to have that filled outer shell. So lithium doesn't really want to attract it because it would rather just get rid of 1. Fluorine definitely wants to attract him because it wants 8. So as we go right, just say, as we go right, the electronegativity increases because as we go further right, the closer the elements are to filling their octet. So fluorine's really close to having a filled octet, a filled outer shell. It really just wants that last 1. Now, what happens if we go upward? Okay, it increases. This is very similar to the ionization energy. Okay, let's look at fluorine compared to iodine. All right, so fluorine, once again, has 9 protons. Okay, it's got those 2 valence electrons, and then it's got 2 inner electrons, sorry, and then 7 valence electrons. Iodine, oh boy, let's actually go with bromine, okay, because I don't feel like drawing all that for iodine. Bromine, it goes on, and I'm not even going to fill all these electrons out. I'm just going to show you the idea, okay? So what happens is, as we go farther up, the ability to attract electrons increases. Why is this? Okay, they both have 7 valence electrons, so they should both attract electrons, but for some reason, fluorine attracts them a whole lot more than bromine. And that reason is just because those electrons are a lot closer to the nucleus, right? There's not a whole lot of electrons in the way here. So this nucleus of 9 protons could go ahead and attract an electron real easily. But with bromine, there's all these electrons in the way, right? They're kind of stealing the pull from all these protons in the nucleus. So if there's an electron out here that needs to be attracted, well, all these electrons are in the way that this nucleus has to move around to attract it, whereas the nucleus in this fluorine can just go boom right there and attract it. Okay, so it's electron shielding again, right? Bromine has a lot of electron shielding, so that nucleus is unable to attract that electron as much, whereas fluorine really doesn't have a whole lot of electron shielding, so it's able to attract that electron no problem. So why does electronegativity increase as we go up to the right? There's less electron shielding as we go up. As we go down, there's more electron shielding, so they're not able to attract the electrons as easily. Okay, so that's the trend of electronegativity. And there's only one thing I want you to deal with here, and that is dipole moments. Okay, dipole moments is what they're called, which is just drawing pretty much the trend of electrons. Now let's look at something like hydrogen and fluorine. Okay, hydrogen has a really low electronegativity, so it's not going to want electrons. Fluorine has a high electronegativity, so it really wants an electron. So when these guys bond together, their electrons are actually really close to fluorine and really far away from hydrogen. So what we do is we draw a dipole moment, which is just an arrow with a plus sign on the end. The one that isn't going to have the electrons attracted to them gets a plus sign by it. And then what we do is we continue that plus sign over and draw an arrow to the fluorine. Okay, that pretty much just tells us that the hydrogen is partially positive and the electrons are going to the fluorine instead. Okay, let's do one for oxygen and nitrogen. Okay, let's look at oxygen and nitrogen. Which one is more electronegative out of oxygen and nitrogen? This is O. O is more electronegative, so it's going to attract the electrons more. So if I were to just put some electrons in here, I would show that they are closer to oxygen. That means the one that is less electronegative gets the plus sign, and the arrow goes this way. Okay, that's the dipole moment. Let's do another one. Let's do calcium, and let's do 2 chlorines, because that's how it would actually look. So we got 3 elements here. Calcium's all the way over here, low electronegativity. Chlorine is all the way over here, high electronegativity. So if these were to bond together, the electrons would be closer to the chlorines. Again, you don't have to draw these electrons. I just do because it makes me feel better. So what would happen is the positive would be on the calcium because it's least electronegative, and the electronegativity would increase as we go to the chlorine. So that's our dipole moment there. And I'm going to get rid of these electrons because you really shouldn't have those in there. But be able to draw a dipole moment. And the last thing I want to show you is just between 2 of the same elements like nitrogen and nitrogen. They have the same electronegativity, okay? So here, there's not any difference in electronegativity. So here we would say there is no dipole moment. Okay, so that's all we're doing. That is as complicated as it gets. Remember, noble gases have an electronegativity of 0, so they're like pretty much down here. Okay, they're never going to attract anything. So francium has a higher electronegativity than all these noble gases, even though it's really far to the left. So that's electronegativity, guys. That's the last trend. Have yourself a great day.